Reliably detecting a specific color is one of the most powerful things that you can teach a robot to do. By the end of this video, you'll be able to set up a camera vision system for the Limelight 3A that can reliably detect any color you want every single time with no coding required. Color identification is a fundamental step in computer vision that lets you build much smarter and much more interactive robots. I'm Brogan Pratt, and as a robotics and design educator for over 10 years, I've helped countless students get started with complex topics just like this one. I'm going to run you through the entire process from the ground up. We'll start with connecting Limelight 3A and accessing its web interface. Then I'll walk you through step by step, tuning the color thresholding, filtering out visual noise and contours, and finally configuring the output settings to get perfect detections. I'll also explain what that means along the way. I'll also give you lots of tips about making your tuning process a breeze as we continue through this. I have a bunch of little colored chips we're going to be using for color blob detection today. I've got yellow, I've got red, and I've got blue, simply because these make it quite easy. These are 2 centimeter by 6 centimeter blobs and about 2 millimeters thick, but the thickness for the reality for this doesn't really matter too much. So getting your Limelight 3A set up to do color blob detection is actually quite simple. We're going to connect it to our computer. We're going to use a USB-C cable into the side of the Limelight. And then you just have to connect the USB-A into any USB port, USB 3.0, in on your computer. Now, when the Limelight boots up, you're going to get a solid light. Orange light means it's on. A quick flashing green light means that an object has been detected. Whereas you'll likely see a slow flashing green light if you're doing this for the very first time. So let's go ahead and get this thing connected. Over on any sort of web browser, if you're doing this on a Windows computer, you can download the Limelight app, but it's not necessary at all. We can go to http://limelight.local:5801. And this is the web interface for the Limelight 3A. And once we got there, I'm going to go ahead and swap this Limelight 3A over to my tripod. All right, so when you first boot up Limelight, you're probably going to get a scene that looks like this. Now, you'll notice that mine's already picking up a blue rectangle because I've already done some calibration here. So what I'd suggest you do is you click this Ignore Network Stable Index button. And now you can go ahead and select pipeline number 9. We're going to use pipeline 9 here as our testing pipeline, just so we can get started. Now, the pipeline type, the Limelight 3A has a whole bunch of different pipelines you can use. You can use April tags, neural detectors, Python snap scripts. There's a lot of cool things, but the purpose of today is just looking at color or retroreflective. So retroreflective is something like if you have a reflective piece of tape. That's what we'll be using there. Now, the image source is camera, but you can also use an image source of a snapshot. So for example, if I look at this screen right now, I can say take snapshot. And then I can use a snapshot and select the one that I want as my image source, and it won't have live updating. So I'm going to go ahead and select camera. Now it comes time to select resolution. Now for color, I highly suggest you use, and from the Limelight documentation, they also suggest that you use 320 by 240 and 90 FPS. Now the reason for that, it seems a little strange to use something that's lower resolution. But for color, the reality is we just need a blob, and you don't need really high resolution for a blob. In fact, if you're doing color, having higher resolution can actually mean you have more likelihood of getting artifacts in there. And for color, using higher frame rates is better. Another point is that if I were to use a 640 by 480, that's over 3 times or almost 3.7-ish times the bit rate of a 320. So it's a lot more pixels for me to calculate off of, and it is going to slow down some cycle times. So by having a lower resolution for color, that's better. Now that changes if we're going to talk about April tags, where you actually do want a little higher resolution, but for color, this is perfectly acceptable. Now, stream orientation allows you to flip things upside down, normal, clockwise, mirror it. It depends on how your camera is set up on your robot itself. Now let's get into some of the tuning here. Exposure is how much light your sensor is letting in. So you can think of a camera's light sensor as being a bunch of grids, and in this case, we have a whole bunch of different pixels, and each one of those stays open for a certain amount of time where it allows light to come in. The higher the exposure, the longer that bucket stays open for you to pick up light. The lower the exposure, the less time that sits in. You actually want to have a lower exposure rate for your camera vision. And we'll have to play with this a little bit as time goes by. We're going to start a little bit lower because you want to have actually a darker vision. Now, it might look dark on my computer. This is actually easier for a computer to see. So the black offset level is for making your whole image a little bit darker. So as I bring this black offset level up, you'll notice that my image starts to get a little bit darker. This is really helpful to play with black offset level if you have really bright lights in your area. So perhaps you're looking up at a different point. And when you look up at a different point, you might see a bright light inside of that section. By updating your black offset point, you can get rid of some of those brighter lights. Now, sensor gain effectively makes your image a little bit brighter while actually adding a little bit of noise. You can see that this kind of gray background that's on here is now becoming quite noisy. You can see those kind of like green and gray and red artifacts that are coming up now. I recommend we start this off about 6 or 7, and then you kind of play with it. You kind of have to play with your exposure, your black offset, and your sensor gain. If you want to have a lower exposure time, you can play with your black offset and sensor gain so that you can still have faster exposure times because they're in 0.01 millisecond cycles without having to increase that exposure more. Now, your red and blue balance is obviously if you're a white balance for the camera. You probably don't need to touch with these, but if you happen to have like really orange lights inside of the space where you're trying to get your camera vision, like a Kelvin 2700 or 2400K light as opposed to a 3000 or 4000 kind of more white light, you're probably gonna have to play with these balances a little bit. So for now, we're actually gonna put input on hold and we're gonna come back to thresholding. Now these ones, you kind of want to get your input mostly set up, but we're gonna come back and play with exposure, that black offset and that sensor gain a little bit as time goes by. So now let's come to thresholding. Now to get into a little bit of theory, how the Limelight's color vision works is it uses an HSV model or hue, saturation, and value model. You can see these right down here. So it plays with these 3 values to be able to know where a object is. The most important one here is hue. So we are going to try to track the blue objects inside of this. So what I can do is I can start with a magic wand, and then we will build from there to be able to play with our hue. So I'm going to select eyedropper. And when I click on a blue pixel, you notice that the hue range automatically moves to try to grab. But it's not quite what we want. Now in my scenario, I only have red, yellow, and blue. So I can actually go ahead and expand this hue quite a bit to be able to catch sections that are more blue. Now, as I start to get into this kind of yellow range, it starts to pick up some of those yellow points. So my blue almost ranges a bit on the teal side. So I'm actually going to expand my hue out quite a bit more so that I'm more likely to catch those. Depending on how tight that hue is you have, you may want to bring those in a little bit. Now, at this point, rather than looking at the color showing, what I want to do is I want to show a threshold. And this makes tuning a lot easier. Now, with a threshold camera, effectively what it's doing is it's going to use this hue, saturation, and value pairings, and it's going to try to say, okay, are these pixels fitting within these values? So you can go ahead and look at these sections over here, and these are all the colors that match the threshold that I've set up of that hue, saturation, and value. So as I expand my hue, you'd see that if I go into red, a lot more objects start to get recognized. But as I expand my hue further into the other side, a little more, a little bit less. So we can actually play with that hue a little bit until it is kind of narrowly catching that point. Now, saturation is a measure of how dark or how pure a color is. So pure blue will be up on 255. A rather faded blue is going to be rather low on saturation. So you can, again, play with this sensor a little bit until you can find a saturation value you're happy with. I like to leave mine a little bit wider in my band. Now, value is a measure of how black something is. So if I have a really low value, you'll notice that the black or that gray background that I had starts being shown up as a true pixel section. So you should drag your value up to a point where you're no longer getting artifacts, but you can't have such a high value that it's actually rejecting ones that should be true. Watch these 3 in the top right-hand corner. If I go in this color section, these 3 here, if I bring my value up too high, you'll notice that it no longer recognizes those as valid pixels. So we're actually going to drag our out, and a little bit of artifacting up here is okay because it's just a little bit of randomness and noise. That's my white What is that? That is just a white section I have from one of my 3D prints up and above. Now, erosion steps is as you bring your erosion steps up, it erodes that confidence value of what it returns. So it's going to bring it down a little bit. In practice, it's going to make your rectangles a little bit smaller. Dilation is going to do the opposite. It's going to make things a little bit wider and it's going to expand that. So if you are having a hard time and you're getting if you're getting too many objects passing through, you can erode one step. So in my case, it looks like as I'm getting a little bit of feedback from up here, I'm actually going to put one into the erode step. If you find that your value was maybe a little bit too high, like so, and you bring up your dilation steps, you'll notice that it's more likely that you're getting a more accurate picture. So I'm actually going to bring up my erosion step by 1 just because that's going to make my picture a little bit more accurate. Now the X crop and the Y crop, or if you want to take out specific sections of that sensor, I just leave mine at full because I want to connect both. Now this invert hue selection is what you want to use for red targets. So for example, if I were to grab a red target, it's going to band between these 2 points, between 87 and 125. Now, if I were to turn on this, what it's going to do is now it's going to catch things between 14 and 165 and it's going to band and wrap around. You only need to do that for red because in a HSV section for picking up color on red, it goes from 0 to 180, and we need a way to band that around in that. But in our case, we're using blue today, so I'm going to go ahead and not turn on that section. But when you want to do a red pipeline, you should do that. Now comes time to look at our contour filtering. In contour filtering, this is where we can keep track of which one we want to look at. So the sort mode is going to choose the object based on your point. So smallest is obviously going to choose the tiniest one. The highest is going to be the one highest in that section. Lowest is the one that's lowest on the bar. The rightmost and leftmost, you can figure out those ones. And closest is the closest to the original crosshairs, that kind of green crosshair that's in there. Now, area or percentage of the image is your target area for how big something should be. And this is of your entire image of the Limelight. So if I take these blue objects, and what I'm going to do, I'm just going to go ahead and throw this on color for you to see what I'm doing. I'm going to take one of these blue objects and I'm going to move it close to another object. So I actually have 2 of them stacked beside each other. And you'll notice now that the Limelight thinks that this is one specific object, despite it rather clearly actually being 2 objects. So what you can do is you can bring down the area percentage of your image until you're left with objects that are less than a specific size. And what that lets you do is it lets you stop when you have objects overlapping. It stops them from picking up those points. Or if you have objects that are touching each other or objects that are stacked right beside each other like these 2 are, it'll stop it from picking that up as one object itself. So you can bring down that area percentage of your image. Now keep in mind that's going to change a little bit if your camera gets farther away and closer to your object. So you have to keep that one in mind a little bit. So the fullness of that blue rectangle is for things that might have empty sections inside of them. So for notice at this piece here, I'm going to go back to color. At this piece, it's like a U. So imagine that I had this all as one solid piece as opposed to as 3 separate pieces. I could bring this fullness in to say that if I were to, well, let's bring up the area of our image again. If I bring our fullness lower, it's only going to select objects that are completely or that are not quite full in. So the width-height ratio responds to things that are going to be showing up in specific orientations. So if you only want to pick up tall rectangles, you can bring that width-height up. If you want to bring rectangles that are flat, you can bring that width-height ratio down. And it will be less likely to pick things up when there's specific orientations. So you notice that in this high orientation doesn't pick it up. When rotated flat, it is able to start picking it up again. So depending on what your object is, you may want to reduce that if you're only going to pick them up in specific orientations. And then, of course, you can get into smart speckle rejection. This is getting rid of random outliers. So if we go back to our thresholding, reduce our erosion step, if I turn on the smart speckle, you'll notice that it starts to reduce some of those random noises up in the top right a little bit. But I'll pull that one down again. and we'll bring back our erosion step up again. And you can see that I actually pulled my area percentage of the image down a little too much because it wasn't actually recognizing any of these as valid objects. So you don't want to play with this one too much. And of course, you can get dual targets. You can get tri-targets. So you can have multiple things being picked up. I've got two that are a little too close to each other here. So we'll go ahead and pull those. And maybe this one is throwing that data out a little bit. We'll open that up a little bit. And now we've got multiple targets that we can be working with outside of here. But for the most part, depending on how many targets you want to pick up, I'm only picking up one. Now, when it comes to the output, this is the targeting region, which is going to tell you the part that's interesting about the object. So right now, you'll notice that I have the main crosshair, and then I have that small crosshair. And we'll move that a little bit out of the way, just so it's not completely grabbing that. That small crosshair is that targeting region, and that's your target of interest. You can change that from the center. You can make it the top of the object. You can make it the right of the object. You can make it the top and the center unrotated, or the bottom unrotated. So for instance, if I were to have my object rotated, and right now I have this bottom unrotated versus the standard bottom, it is going to grab that whole bounding box effectively. So I'm going to go ahead and leave this in the center because I always want to try to pick up the center of the object. Contour reduces the numbers. This is really only useful if you're working with raw corners, which you can send the raw corners as specific values. So you could say send the 0, 1, 2, 3 section of those corners if you wanted to. You can also have JSON over network tables if you want to. You can have single crosshair. You could have dual crosshair if you wanted to. I keep it a single crosshair just for easiness. And then you can calibrate your X, Y. Let's say, for example, your robot always has to shoot slightly to the left of wherever that point is that you're trying to either hit, or its claw is slightly offset from the center. You can go ahead and offset that X value, and it's actually going to offset both your main crosshair a little bit, so you're always going to be moving it to left. But that's up to you to decide if your robot needs to have it offset. And to be honest, you can either offset this one in software like so, or you can offset it in your program's main code. Once you're happy with your pipeline, you can go ahead and rename your pipeline. I'm going to call this pipeline blue. You give it a check mark, and then you can go ahead and download this. This will download a local copy to your computer. I suggest you save this in a separate spot. It already saves it automatically to Limelight, but it's always nice to have a separate copy. Now, one thing I want to note here is that your lighting conditions can dramatically change the output of your system here. So if I were to change the lighting here, you'll notice that I'm getting now different outputs on this. In fact, this little bottom tag is no longer even being recognized because the lighting is so different. But as I move around, you'll notice that as that lighting shift starts to change, we can actually have different objects pop in and out. So you're likely going to have to, depending on your environment, change your hue saturation values, your erosion steps, whatever that is. You're going to have to calibrate your thresholding and your contour filtering a little bit. Well, probably not your contour filtering, but you're probably going to have to calibrate your thresholding a little bit depending on your lighting for the unit for the day. So I hope you found that helpful as a quick walkthrough as to how you can get a color blobbing detection pipeline set up with the Limelight 3A. If you have any questions about this or questions about more values, things like how we went about setting this up, let me know in the comments down below. I'll try my best to help you out further than that. If you're curious about how to set this up for a First Tech Challenge or FTC robot and what you might do with that data, I've got another video down in the description down below about how you can actually use this data to make a robot do something in the context of FTC. Otherwise, best of luck out there on your next robotics project.